Good day, I am from Group 13 and today we will be discussing dielectric spectroscopy and dielectric mixtures. For this project, we are focused on how can dielectric spectroscopy be used to assess the phosphorus content in fruits and vegetables. So first we must ask ourselves, what is dielectric spectroscopy? Dielectric spectroscopy is the interaction between an external electromagnetic field and the electric dipole moment of a material. Therefore, what would be interacting with the electromagnetic field is the fruit or vegetable being tested. As many forms of testing requires some form of damage to the fruit or vegetable, dielectric spectroscopy can be used to test the fruit without damaging it. This helps to prevent breakdown in the tissues of the fruit or vegetable, but still determine the macronutrient context. For the theoretical framework, Nelson research on dielectric spectroscopy of fresh fruits and vegetables provides the properties required to create a model of both a carrot and an orange along with their dimensions. A parallel plate model was then created where one plate represents the terminal and the other ground. A small voltage was utilized as to prevent any form of damaging that can result in a dielectric breakdown. Within the model, epsilon was varied to observe the changes in the capacitance as well as impedance. This provided a relationship between the dielectric and electrical properties, provided that within Nelson's model, the epsilon values related to an average phosphorus content of 35 mg for the carrot and 14 mg for the orange. What was used within the model to represent them were an average value between them. This may provide a minor deviation for their actual values, but would provide their values to be compared to one another. Capacitance and impedance were then recorded to observe changes within the phosphorus content. These values were used to plot graphs showing capacitance versus epsilon and impedance versus epsilon using MATLAB. Within the results, you can see plots of capacitance versus epsilon as well as impedance versus epsilon at frequencies of 10 MHz, 100 MHz, and 1 GHz, obtained from the COMSOL model. From the results, the electrical properties, capacitance, and impedance obtained for the carrot and orange can relate to epsilon based on these graphs. From Nelson's research, providing the electrical properties responding to phosphorus content of 35 mg for carrot and 14 mg for the orange, epsilon shows a positive correlation. If, however, phosphorus content were found to be higher or lower for an orange or carrot, this study can be extended to obtain specific phosphorus content for a variety of carrots and oranges or other fruits and vegetables. Those values can be used, like Nelson's model, to provide more references in which the phosphorus content precisely would lie. In conclusion, dielectric spectroscopy can be used to determine the phosphorus content in fruits or vegetables. Measurements of the capacitance or impedance of a carrot or orange can be done using a LRC meter. The values obtained can be related to an epsilon value based on the capacitance and impedance plots created in this research. As such, an average value can be found for the phosphorus content of oranges or capacitance based on the relationship between the electrical and dielectric properties.